In this presentation, we're going to talk about exceptions and what they are and how we can use them to handle certain situations gracefully. So as an overview, we'll talk about what exceptions are. We'll talk about the history behind exceptions, where they came from. We'll also talk about when exceptions can occur and how to handle them when they do occur. We'll talk about how you can throw exceptions, and then finally we'll talk about how you can create your own kinds of exceptions. So the history of exceptions comes from the language of C, which had return codes when you would call a function. So you can see an example of what we're talking about here. You might say int val gets some function, and this function could do just about anything, but it would return you back some kind of value, and then you would check that value to see how well that function ran. Now, this was a huge burden on the programmer because they had to memorize what all of these return codes meant, and they typically also had to wrap each function call in an if statement. So a lot of times sloppy coders wouldn't do this and they wouldn't check the return codes at all, and then you'd have all of these crashes with your programs. So a little bit later came exceptions, and an exception is basically just an unusual circumstance in Java. It's usually associated when something goes wrong, but it doesn't necessarily have to be. So the main idea is that some methods could possibly throw one or more of these exceptions, and if they do, we need to try to do that method, and then if the exception is thrown, then we need to catch it when that occurs. So let's see an example of what we're talking about here. In Java, there's a thread class, and it has a sleep method inside that throws an interrupted exception, and you can see that right here. But notice that it says throws interrupted exception. When you see a method that says something like this, we have to handle it in a particular way. So going back to the thread.sleep, this is how we would use it. You would say thread.sleep 5000, meaning that you want this program to pause for approximately 5 seconds. Now, here's something that doesn't work. If we were going to try to use thread.sleep directly, you might try to do something like you see right here. We could say system.out.println I am sleeping, then you would call thread.sleep 5000, in other words 5 seconds, and then system.out.println I am awake. However, you're going to get a compile error that says that this sleep call has to be placed in a try-catch block. So something that's a little bit better is to do what you see here. We could say system.out.println I am sleeping, and then we try to do this block of code between this opening curly and this closing curly right here. Now what are we going to try to do? We're going to try to do this thread.sleep for 5000 because this is what could be throwing the exception. Now it may not throw the exception, but it could. So if things run the way that they should, the output is going to be I am sleeping from here up the top, and then it's going to say yawn because it has slept for 5 seconds. It's going to skip over the catch because an exception was not thrown, and so therefore it's going to print out I am awake, and that's why you get the output I am sleeping, yawn, I'm awake. Now what happens if an exception is thrown? Well, it's going to run in a different way. It's still going to say I am sleeping. That's going to print no matter what happens. But then an exception is thrown right here. Now be careful, because as soon as an exception is thrown, we immediately skip to the catch right here, and then we're going to print out an error has occurred. And you can see that right there. And then no matter what, we're going to print system.out.println I am awake. So the output, if an exception is thrown, is going to be I am sleeping, an error occurred, and I am awake. All right, now we do have some rules that are associated with exceptions. First of all, when an exception is thrown, we handle it in a catch section. The program is going to continue to execute unless you do a call to system.exit passing it some kind of number. It really doesn't matter what that number is. I like to pass the number 1, but you could pass any arbitrary number. The exception class is also the parent of all exceptions, so we can extend that class and create our own exceptions, and we'll talk about that a little bit later. And then also you can have multiple catch blocks to catch very specific types of exceptions when they occur. And then make sure that you put the most general one at the bottom. So let's see an example of what we're talking about here. So you can see that we have a try block, and we also have multiple catch blocks down here. So watch what would happen. This try block could throw any number of kinds of exceptions, and if it throws a null pointer exception, this catch is going to run. If it throws an interrupted exception, this catch is going to run, and then if it throws some arbitrary thing like a file not found exception, this generic one down here is going to catch it because it doesn't match these other two, but it does match this because of inheritance. Also with exceptions, you have a finally clause, and the finally clause works with the try catch, but it comes after the try catch. and it's going to execute whether an exception was thrown or not. The only time that this doesn't occur is if you call system.exit, which stops the program in its tracks, and therefore finally wouldn't execute. So here's an example of using the finally. You can see that we have a try block here. We have any number of catch blocks down here, and then we typically put the finally block at the bottom after the catch blocks. Now in this case, whether an exception is thrown or not, the finally is going to print no matter what. Now here's a different example. Notice that the only thing that's really changed is that we have this system.exit. So if an exception is thrown, we're going to catch it down here and system.exit. If an exception isn't thrown, then what's going to happen is it's going to do this try, and then it's going to come down here and print finally. Now it is possible to create your own kinds of exceptions if you want. So for example, we could create a sleep exception, and notice that we extend exception. We have a couple of different constructors here, and that's it. So creating an exception is relatively straightforward. So what if we wanted to get our JavaDog to sleep? Well, we can define a sleep function inside of JavaDog that throws this new sleep exception that we just created. So when we tell JavaDog to sleep, it's going to need to be put inside of a try-catch block. So you can see an example of what we're talking about here. We have class JavaDog, and I've removed the constructor and the other methods, but you can see that we have this sleep method down here that takes in a long, which represents the number of milliseconds that this dog is going to sleep, and then it throws an exception. And notice this is a generic exception. That means that we could throw any kind of exception inside of sleep that we wanted to. We could throw a sleep exception or an interrupted exception, it doesn't really matter. So let's say if the amount of sleep is less than 0, then we can throw this new sleep exception. Otherwise, then we can just call thread.sleep. And if this thing throws an exception, it can come out through this exception right here. Now note that we say that the method throws, with an S on the end, throws some kind of exception, and then inside, when it comes time to actually throw it, we use the keyword throw. So looking at it holistically here, you can see that we create a JavaDog first. JavaDog J1 gets a new JavaDog, passing it away to 14 and Bob, and then we try to make that dog sleep. We've got our try block here. We call J1.sleep. Now realize that this could throw a couple of different kinds of exceptions. If it throws a sleep exception, then we'll catch it right here, and we'll print out sleep exception occurred, and then we would come down here to the finally that says wake up. If nothing occurred, then we're just going to come down here to the finally and say wake up. Or if an interrupted exception occurred because the thread couldn't actually sleep, then we would come down here and say interrupted exception, and then the finally would run and we would print wake up. So in summary, exceptions are typically used to handle errors even though they don't have to be errors. The keywords that are associated with exceptions are try, catch, finally, throw, and throws. Typically, the try, catch, and finally are used in something like your driver, and then throw and throws are used when you define your methods that have some exceptions associated with them. So you try to do a method that could throw an exception, and then you catch the exception when it's actually thrown. Realize that methods are the only ones who can throw exceptions, and also that you can easily create your own kinds of exceptions if you want to. Finally, remember that system.exit terminates the program, so that's the only time that a finally wouldn't occur is if you called system.exit. So that's it for exceptions. Hopefully you now understand a little bit more about them.